Now, on to our last case study. I'm going to let you pause the video, read it, and try to answer the first two questions. Okay. So, if we read this carefully, we realize this is actually a two-tailed test. Bardo doesn't want to make the loaves too light or too heavy, in the same way that Mr. Burns doesn't want too many or too few customers taking out loans. So our null is that the average weight is 16, and the alternative is that it's not equal to 16. Okay. Our sample size and our estimate, well, we know here that when we read the problem, we find out that he takes 60 loaves, and his sample mean is 16.18 ounces. Okay. Notice that all of our conditions are satisfied. He takes a random sample, he has over 30 loaves, and we're going to assume he makes more than 600 loaves. So we're okay, we can use the central limit theorem. So now if the null hypothesis is true, we know that sample means under the null hypothesis are centered at mu naught, and they're going to have a standard deviation. And this could be sigma or sigma hat, but in this case we're given the standard deviation from the sample. It doesn't make any difference as far as our calculation goes. And for this particular problem, this has a mean of 16, and it's going to be 0.8 divided by the square root of 60. Okay, so we're doing a two-tailed test. We know the value that we're looking at, and we know the distribution that it comes from, so we can go ahead and work it out now. So if we go to Excel, make sure we're in the quantitative variable section. I have a sample of size 60, right? My sample mean here was 16.18. Of course, this is the mean under the null hypothesis. This was our standard deviation of the loaves of bread in our sample, and we can easily figure out the standard deviation of the sample estimates if the null hypothesis is true. Okay. So if we think about what's going on here, right? This is our null distribution. It's centered at 16. Again, you look at the standard deviation, it's about 0.1. So this is 16.1, 16.2, 16.3. And if we go 3 standard deviations below, 15.8, 15.7. So our distribution looks like this. So this is what sample means look like if the null hypothesis is true. And our value here is 16.18. And since we're doing a two-tailed test, right, we're going to compute the area in this tail and then the area on the opposite side, the same distance away. So our p-value is going to be twice the area in the tail of our test statistic. So let's go ahead and do that. And we're going to have to be a little careful here, because here notice that our estimator is above the mean. So we're going to have to use 1 minus norm dist, right? So 2 times 100 times 1 minus norm dot dist. Whoops, I need an equal sign there, don't I? Start beginning. 2 times 100% times 1 minus norm dist. And this is my data value. This is the mean. Make sure you hit the right standard deviation, okay? Don't hit the standard deviation of the variable. You'll get a very different answer. And our p-value is roughly about 8%, okay? So we find out that our p-value here, the area of both of these tails together, is around 8%. Well, what do we decide? Well, we know that our p-value is equal to 8%, and that's going to be greater than alpha, which is 5%. So we're going to fail to reject the null. Okay. Our p-value is not less than alpha. So what is our conclusion? Well, we would say at alpha equal to 5%, we find there is not sufficient evidence to conclude the average weight of Bardo's loaves is not equal to 16 ounces. Okay, there's not sufficient evidence to conclude the alternative, and the alternative is that the average weight of his loaves is not equal to 16 ounces. Okay, so now you know everything you really have to have in order to work all the problems.